on 9. So we did a lot with absolute value equations and inequalities, just like solving them. So what we're actually going to work on today is some absolute values and inequalities, but how do they look like on a graph? So first thing I want to have you guys think about, because we're going to talk about this today too, is domain and range for a graph. We'll just start with this in general. So does anybody know, like, what do you think of when you think of the domain of a graph? Like, what are you describing, or what? It kind of connects to one of the variables, but does anybody remember, like, or what am I looking at for domain?
It's like all the x values.
Yes, all the x values it covers. That is a beautiful way to say that. I'm going to write, it's all your possible x values. All right, and if I'm looking at x values, am I going left and right, or am I going up and down? Left and right. Okay, think about your x-axis. The x values go left and right. Okay, whenever you describe a domain, we're going to do these today in that interval notation. You want to go from the left side of the graph to the right as you describe that. All right, so then my range, just the y values, right? We're just going to switch it up. So domains for your x, range is your possible y values for the graph. Any y value you could be using. And this is a little weird maybe for people at first, but I promise it will be helpful. So whenever I describe the range, I always tell people, like, put your pen, pencil, or whatever at the very bottom of the graph and go towards the top. All right, it is how the graph moves up and down, but when you actually write down the interval to describe it for an answer or something, you want to start with the lowest possible value and go to the largest possible value. So you want to go from the bottom of the graph to the top of the graph when you think about that. Okay, now specifically, we're going to do domain and range today for absolute values. And does anybody know just the general shape an absolute value graph makes? That's going to be a quadratic. That's going to be if we have x squared. It's sort of similar. This is a V. It's going to actually have a vertex like a parabola does or like a U shape does, but it comes right to a point, and the two sides, they're not curved. They're both going to actually just be lines. So if we're going to do absolute value, just a plain one first, but sometimes I would do this, like the word absolute value, I would turn the V into a little absolute value graph just to remind myself, but it makes a V shape. And we're going to start out with what we call the parent function, which is just most basic version of the function here. So y equals just plain absolute value of x, nothing added, subtracted, multiplied, just y and x, that's it. All right, for this one, I'm going to make a table. If you plug these values in for x, it should make everything positive when you plug it in. So if I plug in -2, absolute value of that is 2. If I plug in -1, absolute value is 1. Plug in 0, that's going to stay 0. And any positive number is just going to stay positive. So if I plug in 1, that stays 1. If I plug in 2, that stays 2. So we're going to come over and plot these points on this lovely graph. So you should see a V shape forming if you're plotting those correctly. And can anybody tell me what the point 0, 0 is for that graph as a name? Yeah.
Origin of the graph?
It's the origin, yeah. It's the vertex. That's what I was looking for. Okay, all of these guys are going to have a vertex. Point like directly in the middle, and then on either side, you're going to have a, it's a ray that comes out of it, really. So it's going to have the same slope. Well, let me not say it like that. But basically, from that vertex, I'm going up 1 over 1, up 1 over 1. Same thing on the other side, up 1 over 1, up 1 over 1 on either side of that. And that's actually how we're going to graph most of these. We're not going to use all these tables. It can be. We're going to do that on the back. So it has to be altered a little bit in the equation. But yeah, the slopes of the sides can be different. Okay, now, does anybody know, and actually, sorry, let's do domain and range. All right, so domain and range. What are, and you just think about like left forever, right forever, as I'm looking at this graph. What are my possible x values? What do you think? So I've got one ray going this way, one ray going this way. So what are my possible x values? All real numbers, for sure. You're going left forever, right forever. Okay, now I'm going to write that as an interval. So that left side goes to negative infinity. That'll be the smallest value. The right side goes to positive infinity. So all real numbers, you're going to cover the entire x-axis. Okay, now, am I gonna cover the entire y-axis? No. Okay, so here's what I would tell you to do if we're writing an interval. Come from the bottom of the graph. What is the first y value I touch? 0. Okay, now there's an actual point there. That's the vertex, actually, of the graph. So I'm going to use a bracket on this. And I touch the point 0. What would I write as the other part of that interval? In positive infinity, because it's going to go up forever. So I'm just going to write infinity. So it starts at that y-coordinate of the vertex. The rest of the graph goes up forever. So when I write that, I'm excluding this part of the graph down here where I don't have any graph. We don't have any of these y values. Like -6 on the y-axis, I don't have a graph there. So that's not included in the range. It just starts at 0 and goes up forever. Now, does anybody know, for the one right next to this, if I put a little negative sign out in front of the absolute value, what does that do maybe to the graph that I just did? Awesome. Okay, now I'm going to write this, and just so you guys can have it, but this is going to flip this over. The technical term for that, it's called a reflection over the x-axis. And a lot of the stuff we're going to talk about today doesn't just apply to absolute values. It's literally going to apply to all the different types of graphs, the transformations that we're going to do today. So we're going to shift them left and right, up and down, and we're going to actually stretch them and shrink them a little bit on the back. But all these rules I'm going to give you today, these will apply not just for absolute values, but for all the functions we're going to do. So reflection over the x-axis, what it's doing is, if you actually plug these in and make a table like we just did, everything would become positive from the absolute value, but then you're taking your answer and multiplying every single thing by -1. So these are going to be the same numbers in the table before, they're just going to be negative. And if you plot this, this should still be a V shape, it's just going to go upside down. Still has a vertex. And we're just going, instead of going up 1 over 1 on either side, we're going down 1 over 1 on either side of that vertex. What would you guys tell me if I flip that graph over? What would the domain be for the flipped over graph? Still the same, right? All right, this side goes left. Am I backwards? This side goes left forever, this goes right forever. You still cover the whole x-axis. It's just going upside down from what we just graphed. So still negative infinity to infinity. Every single absolute value graph that we're ever going to give you, they have the same domain. They're going to go left and right forever, whether they're turning up or turning down. Now, the range would be different here. Now, I always would tell you, come from the bottom to the top when you describe the interval. This is pointed down forever. So I know I don't have a humongous graph on here, but if I was thinking about how this graph extends, I would constantly be touching part of this graph as I slide my pen up here until I get to the vertex. What would you start your interval with for the range? Awesome, negative infinity. Okay, now, so when you're doing that, you approach from the bottom to the top, so you write the interval correctly. What is the last y value I touch? 0. All right, so it's like capped off, and then there's no graph above that. So the y-coordinate will be where you stop your range if it's flipped upside down, just the y-coordinate of the vertex. Is anybody having a question? Okay, now we're going to shift these graphs. All right, so a vertical translation is going to shift your graph, and it's either going to go, it's going to shift your graph up or down. A vertical translation is going to shift the graph, just shift everything up or shift everything down. Now I'm going to give you a general formula for this. So a vertical translation, I'm going to write y equals, and I'm going to do absolute value of x, and then I'm going to put plus k. K would represent a number, could be positive, could be negative. Outside the absolute value is going to shift the graph up or down, and I'm going to write down the way you think. Okay, so we're going to shift the graph up or down the way you think. So what I mean by that, if it's like absolute value of x and then I have like plus 10, it's going up 10. If I have absolute value of x minus 15, it's going to go down 15. So whatever that number is, it's going to go up or down exactly the way you would think. Now, we're not going to do tables for all these. We're going to just do the vertex, and then we're just going to do like a slope for either side. So I'm going to show you how to do that here. The first example I have for vertical translation here, this is just y equals absolute value of x and then minus 4. Outside the absolute value is going to shift it up or down the way you think. So I see that minus 4. So the shift here is going to be down 4. Can anybody tell me, just from looking at the equation, what the vertex would be? Yeah. What would the x-coordinate be? There you go. Okay, there's nothing inside with the x. It's just x by itself. So nothing inside there. So x shifts it left and right. We don't shift left and right here. We're just going to go down 4. So 0, negative 4 is going to be your vertex. All right, now, instead of making a table, we're not doing that. I promise you this will be easier. So I just have a plain x, right? I'm going to put this in quotation marks, and I'll explain that in 1 second. But your slope, if you just have a plain x, what would the coefficient of x be? 1. So your slope here is just 1. And I'm just going to write 1 over 1. What you're going to do from that vertex, and I'll show you why I put slope in quotation marks in 1 second. Just from that vertex, once you find that, just go up 1 over 1 on either side to create that V shape. And as long as you got about 5 points, that's plenty that you can play connect the dots with to make the 2 rays that make the side of that. Now, I always just say to myself, find that vertex, up 1 over 1, up 1 over 1 on either side. The reason I put that in quotation marks, I'm going to write this for you guys because I know you'll understand this. Technically, the slope of this side would be positive 1. The other side of that V, though, if I was just looking at that ray, the slope of this side is really negative 1. So that's why I put that in quotation marks, because I just say it to myself, just find the vertex up 1 over 1 on either side, so you're taking care of that. But technically that's not, I don't want to put slope there because technically they're opposites of each other as you switch from one side to the other. All right, now, domain, every single one of these, left and right forever, so negative infinity to infinity. It's going to cover the whole x-axis. Can anybody raise your hand and tell me what you would write for the range for this graph? What are my possible y values? Tell me what you think. Negative 4 infinity. Just go ahead and put a bracket with that number because you got that point right there, and we're going up forever. Okay. Does anybody have a question? Can anybody tell me the vertex for the next one? I've got y equals negative absolute value of x, and then plus 5. 0, 5, right? Nothing inside with the x, so it's not shifting left or right, so 0. Copy what's on the outside, that's 5. So 0, 5. All right, we're going to turn up or turn down here? Down because of the negative. Okay, so again, I'm just going to put this in. You don't have to write this on your paper. I'm just going to put slope in quotation marks. It's negative because we're having the negative in front of the absolute value. So just from that vertex, just go down 1 over 1 on either side. And then once you got one of those points, just keep going down 1 over 1 to get another point. Every single graph we're going to do today, left and right forever. One side goes left forever, one side goes right forever. It covers your whole x-axis. So your domain's going to be from negative infinity to infinity. Can anybody raise your hand, write me the range for this one? What do you think? Perfect. Goes down forever, so start your interval with negative infinity, stops at that vertex, which is at 5. It should just be the y-coordinate of the vertex. All right, now, this one's trickier. We're going to do a horizontal translation. I'm going to try my best to explain this to you. Okay, this is going to shift your graph left or right. I'm just using arrows to kind of abbreviate that. So this is going to shift your graph left or right. I'm going to write this the opposite way you think. I will say this to you 1,000 times over the course of the school year. It's going to go the opposite way that you think. Here's how this works. This is going to be y equals, inside the absolute value with the x, you're going to see x minus h. And the h and k, typically, like if you're looking this up online or something like that on a textbook, we have but h and k are used to represent the shifts just kind of universally in any textbook. So that's supposed to be an h. It kind of looks like an n. Maybe make that bigger. Okay, opposite way you think. Now here's the deal. If I just gave you like y equals absolute value of x minus 7, I look at that and go, I think -7. I'm immediately thinking we're going to go to the left. That's not how it works. When it's inside the operation, here it's inside this absolute value, this would actually move the graph 7 units to the right. Does anybody know why it's going to be a shift to the right? Say that one more time.
It's really positive 7.
It's really +7. Okay, do you guys see, if I put in +7 here, what would the inside of that be? If I plugged in 7 for x, what would that make that absolute value? 0. Okay, where it goes to 0, that's where it switches from one side of the v to the other. So it's always the opposite of what it looks like. It's the number you would plug into that absolute value to make it 0, switches from one side of, or one ray to the other on your absolute value. Okay, so when I look at these, here's absolute value of x minus 3. I always tell people, like, just whatever's inside with the x, just write down the opposite of what that looks like to you. So to me, that looks like a -3. So I immediately write down +3. That's going to be the x coordinate of your vertex. Anybody know what the y coordinate would be? 0. There's nothing added or subtracted here, so the y coordinate's just going to be 0. If there's nothing inside with the x, you don't go left or right. If there's nothing outside, you don't go up or down. So this is actually going to go 3 units to the right is going to be the shift here. So I'm just going to graph that 3, 0, and then we're just going up 1 over 1 on either side. So that vertex will be right on the x-axis here. Now, no matter what, domain for all of these is going to be -infinity to infinity. Okay. Now somebody tell me what they think the range is for this question, and I will warn you, it's tricky. What do you think?
Is it bracket 0?
Yes. Yes. Good. Someone was thinking 3. I'm not judging you, but I don't know. For some reason, if it's on the x-axis, sometimes people will accidentally write down the x-coordinate. But the first y value you touch is actually 0. That's just the y coordinate of the vertex, and then it goes up forever to infinity. Okay, can anybody tell me what would the vertex be for the graph next to this? Yes, -2, 0. And now, is this one going to turn up or down? Down. But all that negative does, we're just going to go down 1 over 1 on either side. That's the only thing it does. And so we're going here, still -infinity to infinity for your domain. What would your range be for this graph? I've got it turned upside down. What do you think? -infinity and then 0. Is anybody having a question? Okay, I'm going to see if we can get these two done real quick here. All right. Real quick. So what I've got in this example 3, this is what we call diagonal translation. It basically means you're going to have a shift left or right and up or down in the exact same equation. All right, and I want you to for sure remember this. This does not just work for absolute values. We are going to create our vertex when we look at this equation. We're going to do the opposite of what we think inside with the x, and we are going to copy whatever is outside. That's going to be our y coordinate. That will always be your vertex. So I have f of x here. This is just function notation real quick. That's the same thing as y equals. But I have absolute value x plus 2 minus 5. Can anybody tell me the vertex for that one? Exactly. Opposite of this, copy this, -2, -5. Okay, am I going to go right side up or upside down? Right side up. Just up 1 over 1 on either side. Your domain for all of these here is going to be, oh my goodness, don't look at my graph. I just totally I didn't do it right. Okay, -2, -5. I don't know what I just did. All right, -2, -5 is clear over here. Okay, sorry, you guys. We'll finish up when we come back. Sorry. All right, so green one. All right, now, let's see. We're going left and right forever. So -infinity to infinity for our domain. My range here, I don't touch any part of the graph till I get to that -5 y coordinate. So a little bracket with your -5, and then it's going to go up forever. And I've got one more diagonal translation to try. I've got negative, and then in the absolute value, x minus 4, and then outside the plus 3. Where would the vertex for that one be? 4, 3. All right, we're going to turn up or turn down for this one? Down. Okay, so 4, 3. Make sure I graph this right this time. All right, so now all you got to do, if you're going down, just down 1 over 1 on either side of that vertex to create your V shape. Domain for every single graph, -infinity to infinity. And then the range on this one, you're going down forever. So I'm going to go -infinity, and then I'm going to stop. If I approach from the bottom to the top, I'm touching part of the graph until I get to that vertex, which is 3, and that'll have a bracket on it because you actually have a point there. Yes, ma'am. Okay, no. Okay, that doesn't affect that. All that's going to do is tell you whether it goes down or up. Yeah, so no, yeah, the negative in front doesn't affect how you would find the vertex. So it's still opposite, like that doesn't matter at all. Whatever's inside with the x, it's the opposite, because it's what sets that inside of that absolute value equal to 0. That's where the two sides of the V, in this case upside down V, switch directions. That's a really good question. Okay, and that'll actually come into play in what we're going to do next. Now, this is just like for your information here. So we've already done the reflective transformation, right? If you see a negative in front of your absolute value, that's just going to cause it to go upside down. We just did a diagonal translation, which is a combination vertical and horizontal in the same one. So we're going either left, right, and then up or down. In that general format there's no number in front of this absolute value, so that would just have a slope, if you will, of 1. HK in that situation is always your vertex, and it's the opposite of what it looks like with the x, and then just copy whatever is outside. That's going to be your y coordinate. What we're going to add into the mix for these next two examples here is what we call a stretch or a shrink, and that is going to happen if you have a number in front of the absolute value. Okay, so this is called either a vertical stretch or shrink. There's two things that can happen here. If that value, I'm going to use C to represent that here. If C is a number that's bigger than 1, so like 2, 3, 4, 5, something like that, what that's going to do is it's going to make the V shape more narrow. This is going to be called a stretch. It's a vertical stretch. So it's going to, basically I'm just going to try and draw a more narrow V. The bigger that number is, the more narrow the V shape would be. Now, ignore the negative, because the negative just tells you whether it turns up or down. If that number, I'm going to write a compound inequality here. I'm going to write 0 is less than C is less than 1. So C is going to be between 0 and 1. So like a 1/2 or 2/3 or something like that. That is going to be called a vertical shrink. And what that's going to do to the V shape, it's going to be kind of more flattened out in comparison to what we've been doing. So it's going to make it like wider when you put that on the graph. So vertical stretch like pulls it up and stretches it. Vertical shrink kind of like smashes it down and widens it out. Now, it does not affect how you find the vertex. So if there's a number in front of the absolute value, that doesn't affect anything in terms of finding the middle of the V. And we're going to try one of each in this example 4 and 5. So the first one here, in example 4, and just on the graph for you guys is just y equals absolute value of x, just so we can kind of compare them so you can see how the stretch and the shrink are in terms of the width compared to just a plain absolute value of x. this number, I can spell, I promise, apparently not, is bigger than 1. There's a 2 in front of that, and that's going to be a vertical stretch. So this is going to be more narrow. What would you tell me the vertex would be for the equation I've got in example 4? That doesn't affect how you would find the vertex. What would the middle of the V be? 4, 1. Okay, so opposite copy, 4, 1. All right. Does anybody know, I'm going to plot that real quick, 4, 1 right here. Does anybody know what the 2 would do? Like, how would that affect the graph?
It would be kind of like the slope, so it would go up to over 1.
Exactly. That's all this does. Okay, so I know I keep writing this in quotation marks because technically one side will have a slope of 2 and one side will have a slope of -2. But what I do is just take that number, whatever that is, from your vertex. Instead of going up 1 over 1, you're just going to go up 2 over 1 on either side. Just up 2 over 1. And you'll see this will be much, I mean, it's shifted 4 units to the right and up 1 unit also from that parent function that's on the graph. But you'll see this is a more narrow V shape than the ones that we've been graphing and the one on the graph there. But that's all that does. It's just going to affect like the slopes of the sides. All right, so if I look at the one here, we're just going to ignore the negative. All the negative is going to tell you is that the graph is going to go upside down. That's all it does. It doesn't affect anything else. This is 1/2. So this is going to be what we call a vertical shrink. And it is. It's just going to be the slope of your 2 sides. Because that has a negative in front of it, I just want us to think about going down 1 over 2 on either side. And so that negative I am going to attach to that number there. What would the vertex be, though, for this graph before I try and put it on there? What do you think? -3, opposite copy. So -3, 10. Over here. And then all you do, that number in front is going to affect the sides of the V. So instead of down 1 over 1, you're just going to go down 1 over 2. And again, you don't have to draw a million points. If you have about 5 points, that should be a good idea for you to get a good shape. And then I know this is flipped over, so it's maybe a little bit harder to compare to the parent function that's graphed there, but this is much wider than just y equals absolute value of x. And then this one is flipped over. It's shifted left 3 and up 10. Is anybody having a question? Okay. Now, down here, I'm just adding some inequalities into the mix here, but we're going to try and write the inequality for the picture that you guys can see on the graph. Now, if they look, a couple of these I feel like look a little bit off. They are supposed to have a vertex on a nice point, and they are supposed to have nice slopes on the side that are integers, okay? So, first thing I would do, I'm just going to write, here's a general, and it could be here, x minus h plus k. We'd have the c in front of here. In between here, we're going to have an inequality. So that's just going to depend on the graph. All right, so I'm just going to start with y here. All right, now I've got 2 solid lines that form the V, and the shading is going up. What do you think in terms of an inequality symbol? If I did y there, what would your inequality symbol be that would follow that? Greater than or equal to. You're shading on top of the line, so greater than or equal to. Okay. Do I have a stretch or shrink in this graph? No. It was like a yes or no. I don't. You don't. So you're just, if you just count this, you're just going up 1 over 1, up 1 over 1. So this would just be a plain x. You don't need a value in front of the absolute value. So I'm just going to put absolute value. Okay. What should I put inside my absolute value for this one? X minus 3. And should I put anything outside? Plus 2. Okay. If you guys identify that vertex that's at 3, 2, when you plug that into the formula, the x should be the opposite of what you think. So it's a 3, but it's actually a minus 3 in the equation. The y is positive 2, so it's a plus 2. Okay, let's start out the next one. So I'm just going to do y again. And then is this going to be, like I've got solid lines and I'm shading down here. What inequality symbol would you use for this second graph? Less than or equal to. Sweet. Okay, so less than or equal to, because we got a solid line. We're shading below the boundary line there. Okay, now, our vertex looks like -4, -3. And on this one, I don't think this list looks like up 1 over 1, up 1 over 1. So there's no stretch or shrink here, so I'm not going to put anything in front of the absolute value. What would I put inside the absolute value? X plus 4. Perfect. That x coordinate, if you plug it in there, it should set whatever's equal, or whatever's inside the absolute value equal to 0. And then what am I going to do with the -3? The outside, this is going to the left 4 and down 3 in terms of a shift. So just whatever it goes up or down, you just copy that outside, so just be -3. Okay, now on the last one, I'm going to write y again here. And what inequality symbol are you going to use on this one? Just a plain less than, because the two sides of the v are dashed here. Okay, now, do I have a stretch or shrink in this graph? We do, yes, it's a stretch. Can anybody tell what the slope of the sides are? It's actually 3. I know, I thought it was 2 this morning too, also. So if you get on here and like really get on a point, this is going up 1, 2, 3 over 1. 1, 2, 3 over 1. It's a little bit tricky to see with how small the graph is, but the slope there, if you will, in quotation marks, is 3. So just in front of your absolute value, we're going to put a 3. Okay, now, everything else works the same. This is a little weird. The vertex here is 2, 0. So should I put anything inside the absolute value with the x? Like, what would you write inside the absolute value? This is x minus 2. Okay, so that goes in there. Now, I would never count off points if you wanted to do this. You're not shifting up or down. If you put a +0 on there, that's completely fine. You don't have to. You could just leave it like 3 times absolute value of x minus 2. So either way, whatever's easier for you. Okay, does anybody